Question 10. The figure 3 shows a sketch of part of the curve with equation y equal to 8x minus x power 5 over 2, and x is more than or equal to 0. So the curve crosses the x-axis at the point A, and in part A verify that the x-coordinate of A is 4. Okay, so it's only one mark, and this tells us to verify that x-coordinates of A is 4. So we know A is the x-intercept. Yeah. So if it's x-intercept, y has to be equal to 0. So literally, we just have to substitute x equal to 4 into the equation to see whether y is equal to 0 or not. So if we substitute in, y is equal to 8 times by a, which is 4, and then minus 4 to the power 5 over 2. So if we put that in the calculator, so 8 times 4 minus 4 to the power of 5 over 2, that's just equal to 0. So then that's true. That's our y-intercept. That's the x-intercept. So y equal to 0. So then we verified it. And then for part B, the line L is a tangent to the curve at point A. And then part B, use calculus to show that the equation of line L1 is 12x plus y equal to 48. Okay. So if there's a tangent line, that means we need to use the differentiation to find the gradient first. So differentiate that. dy over dx is equal to 8, and then minus 5 over 2x and power 3 over 2. Just bring down the power and minus 1 the power. And then because the x-coordinate of point A is 4, so if we substitute in x equal to 4, so that would be 8 minus 5 over 2 times by 4 the power 3 over 2. So if we put that into the calculator, so 8 minus 5 over 2 times by 4 the power 3 over 2, that's just negative 12. So if the gradient of that point is negative 12, then the tangent line should have the same gradient as a point. So it's also negative 12. And then we have negative 12 is equal to the coordinates of A, we know is 4 and then 0. So it has to be y minus 0 over x minus 4. Or you can use y equal to mx plus c. That's also fine. Both works. So then y is equal to negative 12x plus 48 if we times the denominator for both sides. So then move 12x to both sides. That'll be 12x plus y equal to 48, which is the same as part B. Okay, line L2 has equation y equal to 8x. And then the region R shown shaded in figure 3 is bounded by the curve, the line L1 and L2. Use algebraic integration to find the exact area of R. Okay, so for this region, it's basically a triangle, but without this part. So we just have to work out the area of the triangle and minus that region. And then that would be the shaded region R we need. So to do that, so we already know this is 4. So that means the base of the triangle is 4. So now we just have to work out the height of the triangle. So if we want to work out the height of the triangle, we need to know what the intersection point between those two lines is. So first step, we just have to find the intersection point between L1 and L2. So we know L1, 12x plus y equal to 48. And then the L2 is y equal to 8x. So we just have to solve the simultaneous equation. So 12x plus y, which is 8x, equal to 48. So then 20x equal to 48. So x is just equal to 48 divided by 20. So 48 divided by 20 is equal to 2.4. And then y is equal to 8x. So 8 times by 2.4 is equal to 19.2. So then the coordinates of an intersection point is 2.4 and then 19.2. So the height must be 19.2. So the area of the triangle is base 4 times by the height, 19.2, and divided by 2. So put that in the calculator, we know the area of the triangle, 38.4. And then now we need to work out the area for this part, under the curve, between the curve and the x-axis. So this is where we need to use the integration. So to use the integration, we just have to integrate the curve between 4 and 0. And then the curve is 8x minus x power 5 over 2 dx, because that's the area between the curve and the x-axis. So we have to integrate the curve. So plus 1 to the power x squared over 2, and then divide by the power, yeah. And then for the other one, again, plus 1 to the power 7 over 2, and divide by the power 7 over 2. And then between 4 and 0. So then 4x squared minus 2 over 7x plus 7 over 2, and then 4, 0. So put in 4 times by 4 squared minus 2 over 7 times by 4 to the power 7 over 2. And if we substitute in 0, it's just 0. So now I'll put in the calculator. So 4 times by 4 squared minus 2 over 7 times by 4 to the power 7 over 2. That will be 192 over 7. So then the final area has to be 38.4, the area of the triangle, minus 192 over 7. So put that into the calculator. That's just equal to 384 over 35. That's it.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.